Thank you for the opportunity to share this work with the title, Enhancing the Priority for the Maintenance Activities of the Hospital's Mechanical Equipment Using the Fuzzy Expert System, done by Irene, Marco, and Alfred, and here presented by Irene Niyonambaza. Maintenance is obligatory to any company to keep equipment and system running efficiently, to increase equipment uptime, and all of those in order to maximize the production. Up to date, the common practice for small and medium-sized companies, including hospitals, is irregular preventive maintenance. This involves physical monitoring of the equipment such as periodical inspections, which could be unnecessary due to the operational status of the equipment, and may include costly periodical professional inspections to identify the exhaust components and servicing. Physical inspections do not promise the full availability of the equipment, as they may be conducted during good life period of equipment, and in this case, it will not highlight any deficit. A continuous real-time monitoring of operating equipment through IoT-based predictive maintenance techniques may increase the equipment availability, lead to the failure prediction ahead of time, increase the equipment availability without timely physical inspections, decrease the unnecessary preventive maintenance, as well as associated costs. Generally, improve the business reliability. A fuzzy logic system, which is based on human expertise, was also proven to be useful in monitoring of uncertain and vagueness systems. It has been deployed in maintenance decision-making process to select a favorable maintenance approach. As of now, the maintenance decisions and scheduling are made thanks to the knowledge of maintainers. Thus, among other decision-making systems, fuzzy logic has been employed in predictive maintenance into different industries as a knowledge-based expert system that may combine available information to provide accurate predictions, suggestions, and scheduling. It is reasonably simple to build as it does not require a theoretical model to rely upon. It shall only require a few sensors to get conditional parameters together with thin, affordable, and energy-efficient computers such as Raspberry Pi to host a fuzzy inference. From literature, fuzzy logic was used to a single component of the equipment, such as rotating parts as the only one crucial for an equipment failure. Yet for complex equipment, the working deficit from each among different components can lead to total downtime of the whole equipment. In addition, the deficit from one component may affect the working status of another component. Though different parameters from each component can lead to make a priority on critical needed maintenance activities to be performed. We noticed that real fault detection and linked decisions on activities priority are at their infant stage and that there is no universal or specific approach to adopt. Furthermore, an autonomous decision-making in maintenance mainly concentrated on administrative and logistic process, but did not reflect on expertise of the maintainers to detect and resolve faults. Therefore, to enhance the maintenance priority decision-making based on an equipment health state, this research contributes by proposing a real-time database fuzzy expert system was inference designed referring to maintainers' expertise. 4 main steps were involved to build our system. We started by investigating the maintenance practices in place, assessing common frequent failures from mechanical equipment and their root causes. Then we selected an equipment as case study and classified in different working condition parameters. This was followed by sorting the condition parameters severity according to the threat that may cause, elaborating possible scenarios of matching different conditions parameters at their different levels to create the rules and priorities. Then the expert system for selected equipment was created and evaluated. The acquired knowledge from maintenance experts, literature, and components market industrial thresholds are arranged into knowledge base consisting of 6 components: input, falsifier, inference engine, knowledge base, diffusifier, and the outputs. Rules and facts are used to generate various variable mapping. The rules can be created using if and then, or if or then, or both or and then syntax to associate more antecedents with their facts. Facts might be generated in view of the threat to equipment that may be caused by the physical condition parameters set. The fuzzy inference engine shall be encrypted in appropriate setup to judge the inputs using rules and facts, then to generate desired conclusion. The steam sterilizer autoclave is selected as mechanical and critical equipment for all sized hospitals. It is used to sterilize surgical instruments, clothes, and dressing materials. It is a must for infection control. General and specific expert data were collected from 2 hospitals and experiments conducted from one of them. The autoclave main critical components and available empirically based thresholds of physical condition parameters were highlighted, and only 4 metrics, which are temperature, vibration, pump and boiler power consumption, are considered as input variables of our fuzzy expert system to prioritize maintenance activities. With those 4 variables, we can detect water flow normality, working stress of the motor, power consumption, and boiler status. These tables respectively show the input and output variables' healthy range. The values range that reflect the fault severity levels and maintenance priority indices are classified by considering previous available data recorded during regular inspections by maintainers on time basis, experiments, standard in literature, operating thresholds, as well as expert judgments, which are also referred to historical data and knowledge from professional training and long experience. The input and output linguistic variables are therefore defined based on the grade of parameter indicators and the effect that could be caused by a certain indicated level. Our input linguistic variables are notated as NO, SS, and VS, whereas outputted maintenance priorities are noted as LO, MO, HI, and VH. The system is designed using a simple library in Python. Simple was chosen because of its simplicity, richness, and friendly usage while implementing any fuzzy membership function. The membership functions are realized using trapezoidal function. Maintenance priorities are related to the urgency level to perform maintenance activity. Low indicates no action is required. Moderate requires close monitoring. High recommends maintenance in near future, and very high calls for immediate action. For 4 selected input, which with 3 variables each, 81 rules are possible using AND operator. In our case, rules have been created by using both OR and AND operators, whereby only 17 rules seizure all possibilities. Our expert system was evaluated using random values in the various defined range for each variable. Bearing in mind that real-time data may change over time due to the working environment of the component, the possible operating universe of discourse for real values from each parameter and their significance to the health status of the component are considered in evaluation dataset formulation. To conclude our work, the system was evaluated and then presented to expert maintainers for their assessment and approval, and they have confirmed the efficiency of the system in making priorities starting from critical maintenance activities. The priority is classified as normal, whereby there is no need of maintenance, moderate, high, and very high, that appears respectively for close monitoring to perform the maintenance within a few days, and for immediate or closer maintenance intervention. We expected that this system will provide support to the maintainers in continuous monitoring of their equipment, early fault detection, as well as in enhancing the priority making of critical maintenance activities, among others. Therefore, it can be adopted to enhance the existing prioritization method for small and medium-sized companies. Thank you for your kind attention. Comments and suggestions are most welcome.